that number, although it's measured as average over 5,000 days, it's still not very accurate. Okay? Each day is so noisy, even you after having so many days, there's still a lot of potential variation in that number. Okay? The standard deviation is 1.76. Okay? If you want to put, typically when you do a survey, you have a mean, then you plus minus 2 standard deviation. That's sort of a range you feel comfortable. Okay? But if you put this plus minus 2 standard deviation, that's going to cover a very wide range. Okay? So the lower bound, let's say mean minus 2 times standard deviation. That's 76, 52. So this is 23. This is 20. Okay. So you put 2 standard deviation error bands. The lower bound is as low as 23 basis points. That's I'm sorry, 0.23 basis point. This is 3. This is 3.52. Okay. So the lower bound, 2 standard deviation lower bound, is 0.23 basis point. So usually we call this one number the sample mean. We call this the point estimate. If you just ask me, give me one number, what's your best estimate? 3.75. Okay. But typically a statistician will say, okay, this is my point estimate, 3.75. But my range of potential mean can be as low as 0.23 and can be as high as, what is the upper bound of 2 standard deviation band?
4 point something
2 standard deviation
plus
That's upper
That's,
bound.
you mean,
You mean
upper bound, right?
upper bound 7.27 basis point. Okay, these 2 standard deviation error bands covers quite a wide range. Okay, so how much does that cover? Probability-wise, that's what we call the confidence interval. Okay,
50%.
So here, I want to make this very clear. Here, we're not calculating the typical one-day return distribution. We're trying to calculate the distribution of the mean estimate. The estimate has a mean of 3.75. The estimate per se has some deviation is 1.76. Okay? So what do we mean by 95% confidence interval? So we want something, so here, plus minus 2 standard deviation band covers actually pretty much 95% of the area. So if you put a lower bound, you put an upper bound, okay? And this area in between is the potential true mean return, okay? Positive range of true return. The 95% confidence interval just says, give me a lower bound and an upper bound such a way that this area between lower bound and upper bound, 95% of the case, the true value will be in there. Okay? So 95%, how do we find out the lower bound and upper bound associated with 95% of probability density?
Just on
these scores are 2 and
Almost like that. Exactly. So put it this way: if this is 95%, how much is here?
0.25.
And how is that?
125.
Okay. So basically, this is using this Z-score table another way. You're looking for 2.5% in probability. You start looking in the middle. for 2.5% probability, and then you find out what that Z-score is. Okay? And then you look for, you're looking for probability, you can't have negative. All numbers is positive. Look for 0.025 or 2.5%. Okay, and then find out the Z-score. What is that? Minus 1.96 give you 0.025. Okay? So the lower bound corresponds to a Z-score of minus 1.96. Okay? The lower bound minus 3.75 mean divided by 125 standard deviation is minus 1.96. Okay? The lower bound for the 95% confidence interval, you do the math, is 3.75 minus 1.96 times, I'm sorry, no, 1.76. The standard deviation is 1.76. Okay? That's why if you look on top of the previous page, the rule of thumb just say, all right, this is 2. 2 times standard deviation plus minus, that's your possible range. Okay, but that corresponds to almost 95% confidence interval, which has an exact Z-score of 1.96. It's not 2, but it's almost like 2. Okay? So, what about the upper bound? The upper bound has a right tail of 2.5%, or the cumulative probability of 97.5%. Okay? If you look at 97.5%, you're going to see positive 1.96 because of symmetry. Okay? So the upper bound gives you a z of 1.96. This is equal to 375 plus 1.96 times 1.76. Okay? So, all right. So let's say you really want to be accurate. Instead of 95% confident that the true value is inside the interval, you want to be 99% confident. Where do you look? What's the probability you should be looking at in order to find a Z-score? So if it's in the middle, carries 99%, how much is on this tail?
0.25. 2.5.
Half a percent, right? You got 99% in the middle, you got 1% for 2 tails. So on one tail you have half a percent. So look for 0.005 on the table. And that gives you what? Minus 2.57.
Minus. What is it?
2.58.
What is it?
It's halfway, somewhere between
Minus
2.57 or minus 2.58. Okay?
It was minus 2. Why 8? 1.
2.57 or 2.58?
Okay? So we're looking for this branch where it's going to cover 99% probability. Okay? This is the 99% confidence interval.
Mm-hmm.
Okay? What's the z-score here?
This is the 95.
2.7, 2.8, no big deal. So here, upper bound, the z-score should be positive 2.57.
Yeah, but
Okay? So this is the z-score. So what's the return? What's the return corresponding to the z-score?
2.57.
Return is the mean, 375, minus standard deviation, 1.76, times the 2.57. The upper bound
99.9.
plus. Okay? So if you want to be 95% confident, you need to start at mean, go left
257
and right
both.
for 2.57 times standard deviation. Okay? What if you only want to be 90% confident?
So,
it's 1.64.
so the A that you mentioned, is the standard deviation of the mean, right?
Hey,
Earlier, I'm just trying to make sure I understand the 1.76 basis.
1.76 basic point is the standard deviation for the mean estimate.
Right, okay, meaning that we.
Here, we try to assign a lower bound and upper bound for that estimate.
But then, and you need to put a mean estimate was derived from the standard deviation of the daily return.
Right, yeah.
Divided by the square root of the number of days.
So it's like the sample.
Yeah,
mean of
you're
the-
gonna see, you're gonna see the next question. The next question, will do the same thing.
So the range is just that, for 95%, it's solving the lower boundary and the upper boundary. So it'd just be actually completing that math, that's the confidence with 95%, and then the confidence with 99% is the other sheet. So it's just, I did the math, it came out between 0.3 and 7.2.
Yes.
For 95%, and then negative 0.77 and 8.27 for 99%. Does that sound right?
Yeah. So that's one interesting fact, okay? If you want to be 99%, if you want to be 99% confident, lower bound actually is negative. Which is to say, if you want, there's still a chance, pretty good chance, that's, 1% chance that daily stock return average is actually negative. That's okay. Which is, it's just, the stock market return is so noisy, it's just very hard to know exactly what's the true average tendency. Even with 5,000 days of data, we still can't pin it down very accurately. Yes. Anybody?
Yeah, Professor, on the earlier example, why did we multiply it by 2? And over here we're multiplying it by 2.57.
So the two, I'm trying to give you, usually when we do a survey, plus minus 2 times standard deviation is just a rule of thumb, okay? It corresponds to almost 95% confidence interval. To be exactly 95% confidence interval, it should be 1.96.
Yeah.
It should be plus minus 1.96 times standard deviation. But if you want to be even more accurate, you want to include a wider range to cover all the possibilities. Say you want to cover 99% chance, then you need a 2.57 times standard deviation plus minus.
It's like a standard
Okay.
table. Right.
Yeah.
Typically, when CNN give you a survey, and that they usually do 2 times, plus minus 2 times standard deviation. That's it. Okay.
Got it.
Usually it's good enough. Okay. But just keep in mind that corresponds to 95% confidence interval. Okay.
Six.